Welcome back, everyone. Today we're diving into an explainer covering a massive agricultural headache that pretty much every grower has faced at some point. You know the drill: stunted plants, those frustrating yellowing leaves, and that seemingly endless, wildly expensive cycle of pouring chemical fertilizers into the dirt with little to no real result. Well, today we're going to look at the exact mechanics of what's going wrong underground and, more importantly, how to fix it. So let's jump right in.
It's a completely natural instinct, right? You see a weak, yellowing plant, and you immediately reach for a heavy dose of chemical phosphorus, hoping to stimulate those roots. But what if I told you that this reflex is actually a trap? Seriously! These highly salted chemical solutions are the primary culprits making your soil hard and compacted. They make your plant's roots incredibly lazy, and over time, they slowly kill the living ecosystem right beneath your feet. And the sheer scale of the financial waste here, it is mind-blowing. Think about this. Under typical farming conditions, for every $100 you spend on chemical phosphorus fertilizer, $75 is instantly locked away by the soil. It just becomes calcified and totally inaccessible to the plant. You are essentially throwing away 3/4 of your money every single time you fertilize. Crazy, right? But don't worry, we're going to get that money back. Here is our roadmap for this explainer. We'll quickly move through the chemical trap, check out the microscopic network, and learn about unlocking stolen wealth. Then we'll cover the propagation blueprint, hit on 4 deadly mistakes you absolutely need to avoid, and finally talk about becoming the ecosystem manager. Okay, starting off with part 1, the chemical trap, and how fast food basically starves the soil. You know, when you constantly supply easily absorbable, water-soluble chemical phosphorus, you're essentially spoon-feeding the plant. It's plant fast food. Sure, the roots might grow quickly at first, but they become extremely lazy, weak, and shallow. The plant literally loses its primal instinct to forage deeply for its own nutrients. It becomes an addict. Contrast that with natural foraging, where roots are deep-reaching, self-sustaining, and highly resilient to drought. When a plant is spoon-fed, it just completely collapses the moment it faces any real adversity.
So the really crucial point here is what happens underground when that addiction takes hold. See, plants and soil microbes have this amazing bidirectional trade agreement that has existed for millions of years. Plants produce sugar through photosynthesis and use it to, quote-unquote, pay biological workers in the soil to mine minerals for them. But when you dump chemical phosphorus right at the plant's base, the plant gets lazy. It thinks, well, why should I spend my hard-earned sugar when the food is sitting right here? So it just shuts off the sugar supply. It stops paying its workers, and that underground biological ecosystem literally starves to death.
Moving right along to part 2, the microscopic network. Let's meet the unsung heroes of the underground. Enter mycorrhizal fungi. Now, please note, this is not a fertilizer. It is a symbiotic living infrastructure. I want you to think of it exactly like a high-speed fiber optic internet cable buried underground. It physically connects the root systems of all the plants in your garden, sharing information and expanding the plant's nutrient gathering range to a scale that's honestly hard to even wrap your head around. Without this living contract, 90% of plant species on Earth just couldn't survive. The reason these fungi are vastly superior to plain old plant roots really just comes down to size. Plant root hairs are kind of thick and clumsy, usually about 10 to 20 micrometers in diameter. They simply cannot fit into the microscopic crevices of clay to get water or minerals. But the fungal hyphae? They are surgically tiny, just 2 to 5 micrometers. They act as millions of tiny microscopic straws, effortlessly squeezing into the smallest pores of the soil where plant roots simply cannot physically reach. And because of that microscopic size, this living network expands the root reach of your plants up to 700 times further into the soil. 700 times. I mean, that is a monumental increase in the plant's ability to forage for its own food and water. All right, part 3, unlocking stolen wealth. Time to take back your locked fertilizer. So these mycorrhizal fungi aren't just super long straws, they're actually brilliant biological chemists. When they bump into that calcified, locked-up chemical phosphorus sitting in your soil, they excrete a special enzyme called phosphatase. This acts exactly like a heavy-duty biological detergent. It literally melts and dissolves those hardened phosphorus rocks, turning them right back into a form the plant can easily drink up. It's the ultimate biological heist. And the benefits don't stop at just unlocking phosphorus. Plants integrated with mycorrhizal fungi have 5 times the drought resistance of isolated plants. Since those microscopic fungal threads can pull hidden water reserves from deep, deep underground crevices, your plants can easily thrive through severe dry spells that would absolutely kill a chemically dependent, spoon-fed plant. The economic and biological return on investment here is pretty incredible. By reestablishing this fungal network, you can reduce your chemical fertilizer needs by up to 50% every single year. At the exact same time, the actual absorption of phosphorus by the plant increases by 30 to 40%. So you're spending significantly less money, all your plants are getting significantly more nutrients. It is a total win-win. Now for part 4, the propagation blueprint. Let's look at exactly how to multiply this fungal workforce. Okay, listen, before we do anything, you must internalize this golden rule. Fungal spores must make direct physical contact with young roots. I really cannot emphasize this enough. If you just grab some mycorrhizal powder and scatter it on the surface of your soil, you are literally throwing your money out the window. It'll do absolutely nothing. It has to physically touch the roots to form that symbiosis. So, let's walk through the specific 3-step process for perennial plants, like fruit trees. Step 1, dig a shallow trench, about 5 to 10 centimeters deep, right around the canopy projection line. That's usually where the most active young feeder roots are hiding out. Step 2, sprinkle 20 to 40 grams of the fungal powder directly into that trench, making absolutely sure it touches those young roots. Step 3, immediately cover it back up with soil to protect the spores from the UV rays of the sun. It is really that simple, but again, that physical contact is totally non-negotiable. Next up, part 5, 4 deadly mistakes. These are your crucial rules of engagement for biological farming. All right, here are the 4 things that will instantly destroy all your hard work. First, absolutely no chemical fungicides, particularly copper-based ones. They will wipe out your beneficial fungi in a heartbeat. Second, over-applying trichoderma initially. We'll get to exactly why in just a second. Third, deep plowing or tilling. Think about it. Every time you violently turn the earth, you are physically tearing apart and shredding that delicate microscopic fiber optic network we just built. And fourth, as we just covered, never just scatter the powder on the surface. Let's zoom in on that warning regarding trichoderma for a second. Now, trichoderma is an excellent, highly beneficial fungus used by a ton of growers, but it is intensely aggressive. If you apply a high density of trichoderma at the exact same time you apply those infant mycorrhizal spores, the trichoderma will actually perceive the unestablished mycorrhizae as a hostile target and completely destroy it. So you must let your mycorrhizal network get established first before bringing in heavy trichodermal populations. Finally, part 6, the ecosystem manager. This is a complete paradigm shift in how we farm. For decades, let's face it, we've acted like exhausted laborers. We've been constantly battling nature, treating the soil as just a dead, empty vessel that we have to artificially pump full of chemicals, which just leads to hard, compact dirt and endless expenses. But when you start utilizing these biological mechanics, you upgrade yourself to an ecosystem manager. You start coordinating living biological systems, letting the fungi do the heavy lifting to unlock the immense nutrients that are already sitting right there in the soil. And honestly, that leads us to the core thesis of this entire explainer. We don't need to add more, we just need to unlock what's already there. Your soil isn't empty, it's just locked. By bringing back the fungal workforce, you can stop paying for fast food fertilizers and start utilizing the incredible wealth that is already locked up in your land. I want to leave you with this final thought and a bit of a challenge. Right after this, go outside, dig your hands in, and grab a handful of your own soil. Really look at it. Ask yourself, is it soft, porous, and alive? Or is it hard, compacted, and dead from years of chemical dependency? The choice of how you manage that ecosystem moving forward is entirely in your hands. Thank you so much for joining me on this explainer, and I'll catch you in the next one.